Let's do a few examples using the quadratic formula. So first of all, I do want to notice that we have a couple methods for solving quadratics. And for this quadratic equation, since it's in standard form, if I was trying to think of two numbers that multiply to give me -3 times -5, which is 15, and add to give me -1, I can't think of two whole numbers that will do that for me, right? So I need a different method. This one won't work. So first, we need to first recognize what are A, B, and C, the numbers, the coefficients that we plug into the formula. So A is going to be -3, the coefficient of x squared. B will be -1, the coefficient of x. And C will be -5, the constant term. Okay, and now first, I'll think about the discriminant, b squared minus 4ac. I like to do that calculation first. So I've got -1 squared minus 4 times -3 times -5. So this becomes 1 minus 4 times, what is this, 20, so 60? 1 minus 60, which is -59. Okay, so since the discriminant is negative, I'm going to be taking the square root of a negative number. I'm going to have two complex solutions. So now when I do this formula, x is -b, so -1, plus or minus square root of the discriminant, which I found was -59, all over 2 times a, which is -3. Let's go ahead and simplify that. See, once I do the discriminant, if I calculate that first, it makes this calculation way easier. So this will be 1 plus or minus the negative underneath the root symbol comes out as I. And I can't simplify the square root of 59. It's just going to stay as is. All over -6. Okay, so there is my answers. There's two of them. And notice that you can kind of break them up. You can write them as two separate things, like x equals 1 plus I root 59 over 6, or 1 minus I root 59 all over 6. You also can split these up. Notice, too, that these are conjugates of each other, right? And notice that you can also split it up if you have to. You can write it as 1 over 6 plus root 59 over 6i, or 1 over 6 minus root 59 over 6i. So if you wanted to write it as two separate terms, like a real part and an imaginary part, you can do that. It does not matter which one of these you use. Let's do another example. -2x squared minus 5x minus 7 equals 0, using all of these steps. So first step is to identify that a is -2, b is -5, c is -7. And let's calculate that discriminant first. So we've got -5 squared minus 4 times -2 times -7. What does this become? 25 minus 56, or -31. Again, notice I'm going to have two complex solutions here. Let's go ahead and write those two solutions down. You get x equals -b, so b is -5, so +5, plus or minus the square root of the discriminant, which is -31, all over 2 times a, which is -2. So simplifying, I've got 5 plus or minus the negative underneath the radical symbol comes out as I, root 31, all over -4. And of course, this is a valid answer, or you can split that up to x equals 5 plus I root 31 over negative 4, or 5 minus I root 31 over negative 4. And also, you could split each one of those fractions up as two separate fractions, if you want. So 5 over negative 4, you got negative 5/4 minus I root 31 over 4, or negative 5/4. And then here you've got negative over negative. That'll be a plus I root 31 over 4. So either way you want to state your answer should be fine. Let's do one last example. 4y squared minus 5y equals 3. Notice I first want to move the 3 over so that I'm dealing with my equation in standard form so that I get everything to one side, 0 on the other. So I'll subtract 3 from both sides. You get 4y squared minus 5y minus 3 equals 0. Making sure to identify that a is 4, b is negative 5, c is negative 3. Now let's calculate the discriminant. B squared minus 4ac. So I've got negative 5 squared minus 4 times negative 3. So this will be 25 plus, what is this? 12 times 4 is 48. Which is 73. Notice I get a positive number out. That tells me I'm going to have two real solutions. Let's go ahead and find out what they are. So x will be negative b, so positive 5, plus or minus the square root of the discriminant, which I actually already calculated was 73, all over 2 times a, which is 4. 73, I can't simplify that, so I'm just going to leave it. This will be 5 plus or minus root 73 all over 8. So there's my two answers. Again, I could be done at this step, or if you like to split it up, you could write it as 5 plus root 73 over 8, or 5 minus root 73 over 8. Or if you really want to, you can split up those fractions even further. X is 5 over 8 plus root 73 over 8, or 5 over 8 minus root 73 over 8. Again, notice when you have two like complex or radical solutions, they will always come in conjugate pairs like so. Okay, so really any one of these solutions is going to be valid. So when you're solving using the quadratic formula, first you want to make sure, and you'll be able to use this on every exam, make sure that you have the formula with you. Make sure that you're first starting with the equation in standard form, everything to one side, 0 on the other. Then make sure you identify what's A, what's B, what's C. And to make the calculation easier on you, first calculate the discriminant, figure out how many solutions you have, and then go ahead and calculate the entire solutions.